Hello, everyone. We are back from the break and we're ready to keep going. Please welcome Amir Siddiqui, data scientist at T-Systems. He will walk us through the process of building an MPC server for code explanation with Llama. Amir, the stage is yours.
Hi, thank you for the introduction. Uh, Let me share my screen first to share PPT. Please confirm you can see the PPT.
We see it. Thank you.
Oh, great. Hello, everyone. Thank you for joining this session today. My name is Amir Siddiqui, and I'm joining from India. I work as a data scientist with T Systems. I have overall 10 plus years of experience in the field of AI and data science. You can also connect with me on LinkedIn. So this is my LinkedIn ID. And I also have a YouTube channel where I usually post videos about data science, AI, now generative AI as well. So you can also check out the videos there. Now, let's talk about the agenda, what we are going to see today in the session. So we'll talk about MCP. It's what is MCP and why we need it, its architecture, and then how it is different from similar protocols like LangChain, Llama Index, Creo AI, some of its core components, and how we can use MCP in data workflows. After that, there will be a demo where I'm going to show you how we can use MCP for code explanation, and we can even use MCP to read code from GitHub and get the explanation out of the code. Now, let's start with the theoretical part first. So, MCP is developed by Anthropic in the year of 2024, and this was the missing layer in the current AI infrastructure. Now, Anthropic is an AI company in San Francisco, USA, and it was developed or it was founded by some of the researchers from OpenAI. Now, the main purpose of this company is to build LLM models, and you might have heard about Claude. So they have Claude 1, Claude 2, Claude 3, and now they have even developed Claude 4. You might have used these models, and maybe if you are using Perplexity AI, which is a search engine, they provide these Claude model as well, and they are really great models. If you compare it with the GPT, they are really good and very useful if you are writing code and you need help in reasoning. So these are very good models. Now, why and how this MCP started? So we have this generative AI, and but there is a problem with the current AI integration because everyone is building their own application, and if you want to connect to that, then you have to write different codes and different protocols. So you need custom adapters everywhere to connect to these application. That is one of the problems. So if I am developing a code or if I am creating an application, then I have to write some custom code for that to integrate it with the other platform. There is no standard interface. Everyone is developing their own interface here. Then there are also duplicated authentication logic. Nobody is providing the same authentication code. Everyone is developing their own code. That is also one of the problem. Then it is also difficult to audit the access that we are making to these applications. And also we have these different frameworks, for example, LangChain, Llama Index, Creo AI. AutoGen, and many others. So they all have their different protocols. Then also there is a risk of security because you have to make sure that when you are having these AI application, they should be secure. So these are the problems or the challenges that the industry was facing with relation to the integration of this AI tools. And then the MCP came in to solve these problems. So let's try to understand what problem it solves and what MCP is. So it is a bridge between LLMs and your external tools, or maybe your code, data, APIs. So now you have on the one hand your application, and on the other hand you have your tools. Tools are maybe some functions, or for real time you can use APIs or even data. And in between these two, there is a protocol which is Model Context Protocol, MCP, developed by Anthropic. Now it has two important component. One is server and the other one is client. Server is where you write your tools, or you call your APIs, or whatever function you want to use, you put everything in that server file. And then there is a client. So client is the user that uses those tools. So you will call those function from your client file. These are the two important components of MCP. If you understand these two components, then MCP is very easy to understand and easy to use it. Now, using this MCP, AI application can connect to different data sources. Now it can be your local files, databases, APIs, external tools, search engines, or anything. If you use ChatGPT, what you do, you have to upload your files or you have to write your code online, but it cannot access your local files. You have to go there and you have to upload it. And if you are using a free version, then there is also some limit. You can upload maybe 5 to 10 files in a day. But with the help of MCP, it can access your local files, your local database, and that it can be used by those applications. So that is one of the main difference between the MCP and the current AI tools. Now it is language agnostic. That means that it can be used by any language, maybe Python, JavaScript, Go, or any other language as well. So it is not language specific, but language agnostic. It also works with any LLM provider. So we have this GPT, then we have Claude, which is developed by Anthropic. Then you can use it with Llama, which is from Meta, Mistral, and there are many other LLMs in the market. You can use it and it works with all of them. Now, for data science also, it becomes or it is very helpful. It gives you a good solution. It is a standardized protocol now for all the connections that you make to the application. So if you look here, this is your AI application. Now, if you want to connect to this AI application to this database or maybe code server or cloud, so you don't have to write different codes or different protocols. In between now we have this MCP. So your AI application and these are your different tools. In between we will have this MCP, and then it will become very easier for your AI applications to connect to this. So this is the solution it provides for your current data science integration. Now let's try to understand its architecture. It's very simple. And if you understand the architecture, then it will be very easier for you to make this MCP protocol. So as I've said in the first slide, there are two important components. One is your MCP client and the other one is MCP server. So in your MCP server, you have resources, tools, prompts. tools are nothing but maybe your custom user defined function or APIs or anything else, live streaming data you want to access. So everything you can put in this MCP server. And here are some examples. So I made some mistake here. Instead of writing these different names here, I have written database everywhere. Now, so here you can have database APIs, then your code, or even some any external tools that you have. And once you have all of that in that MCP server, you will create a MCP client where you will use any LLM model, and then you can make a call, and the call will go to this resources. Maybe the LLM will decide whether it wants to use a tool or an API, or even if it want to call a prompt, and then it will use it and give you the output. So between this client and server, there is this MCP protocol. And this diagram will, or this, yeah, this architecture or diagram will give you a better understanding. So this is a MCP standardized protocol. Now, here you will see on the left hand side, you have all the AI application. These are the AI application. And on the right hand side, you have data sources and tools. So in this data source and tools, you can have some file system or database, for example, PostgreSQL, your G Drive, Google Drive, then SQLite. You can also have these development tools, for example, Git. Then you can also use your day-to-day tools like Slack, Google Maps, or maybe any other applications that you want to connect to it. And then on the left-hand side is how you connect to these data sources or these tools. So you can use Cloud Desktop or LibreChat. Then in IDs and code editors, so you have this Cloud Code, which is again developed by Anthropic. And also you can use some applications. And these are just an example. These are not limited to these applications only, but there can be many applications. So you have this super interface and then other application as well. And this is a bidirectional data flow. That means the data will flow in both the directions. So this is an overview of how the data flows in an MCP server. Now, how this is different from uh, other protocols, or maybe you can say similar protocols. So in the rows, we have different let's say about resource types or how it can communicate. And in the columns, we have different tools, for example, or protocols. So in the first column, we have MCP. The second one is OpenAI functions. Third is LangChain. And the fourth one is Creo AI. Now, the first one is standard. It is MCP is open protocol. So anyone can use it. It was open sourced by Anthropic. And for OpenAI, it is a proprietary of OpenAI. So you will have to use their functionality only. LangChain, it is a framework that can be used to develop GenAI application. It is not a protocol. And Creo AI, it is also a framework that can be used to develop GenAI applications. Then vendor lock-in, none. I mean, you can use it with any vendor, but for OpenAI function, you must use OpenAI only. For developing LangChain applications, you have to use this LangChain functionality only. So it is dependent with LangChain. And similarly for CreUI also, it is dependent on this CreUI functionality. Now, there are different resource type that can be used in MCP. So we have resources, tools, and prompts. In the next slide, we will see in detail about what are these resources, tools, and prompts. So let's leave it for the next slide. Now, OpenAI functions. Here you can use only tools. LangChain and CrewAI, it is ambiguous. I mean, you can just create some applications here, but nothing more than that. Then transport is how MCP connects to your client. So there are three different types. The first one is standard input output, and this SSC and WebSocket, it is for live streaming. For OpenAI, you can use HTTP to connect, and for LangChain and CrewAI, they have their own built-in functionalities to connect. And security model, so you can define your security explicitly. For OpenAI functions, they have their own security standard, and for LangChain and CrewAI, they have this ad hoc security. Now, let's talk about the core components that we saw in this earlier slide, these resources, tools, and prompts. So resources are nothing but you can expose your data to any AI models, and this can be your data can be in files, maybe CSV file, Parquet files. It can be in databases or it can be in APIs. So it can access your local files, unlike ChatGPT, where you have to explicitly upload your code or maybe images or your PDF, but it can in case of MCP, it can access your local files. Now it is read only by default, and it is URI based addressing. So you have to give the path, then it can access that file. Tools, tools are nothing but they are functions. You can write some custom user defined function. For example, if you want to add two numbers, you can define a function add. If you want to multiply two numbers, you can define a function multiply, and that will be known as tools. So these are just the basic example that I am giving, but in real world scenario, you have complex functions that you write to do the task, and they are known as tools. Then you can run queries. You can even use it to modify data. It can also do the input validation. For validation, you can use Pydantic that will validate your input. And it can also do the error handling. You can write functions to handle errors. Now, prompts is also one of the core components. So you can write some functions to uh, use those prompt templates. So you can call those prompt templates and it will give you a better output. You can also parameterize instructions, and this will give you a consistent AI or consistent output because of this better prompting. Now, how MCP can be used in data science workflows. So we can use it in data exploration and pre-processing. That means we can do the EDA. We can also use it for feature engineering. We can use it for the deployment in product, and also for collaborating with teams and doing some experiment. Now, in the first part in data exploration, and here you can connect to your data warehouse or even your data lake, and it can be anywhere, maybe your SQL or cloud database like Snowflake, Google BigQuery, Amazon Redshift, and other data sources as well. What it can do, it can read and transform files, and the file format can be a different like CSV, Parquet, HTF5. So this is Hadoop file format or even Excel. So there can be different file formats here. Profile data quality and detect anomalies. So You can write some data quality rules to do the data quality checks. For example, you want to check some missing values, or maybe you want to see if there are some junk values in the column. So you can do the data profiling, and you can also detect anomalies if there are any in the data. It can do that. Handle missing values and outliers. So anomalies and outliers, they are actually same, but just the different wordings here. Now, in feature engineering, you can access feature stores. Now, feature stores, they are hosted on different clouds, or maybe you can have it in your local files also. Then you can generate some statistical summaries to get the basics idea about your data. For example, mean, median, standard deviation, minimum, maximum, how spread the data is. You can even find correlations between different variables. It can be numeric or maybe categorical as well. You can also create engineered features via registered tools. So whatever tools you write in your MCP server file, you can use that tools and then create some new features out of the existing one. Maybe for example, you have birth in year, let's say 1990, then you can use a function and then you can calculate from 1990 till today and calculate the age of that person. Then you can also check for data drift if your model is getting some new data, and because of that your accuracy is going down. So you can do the detection of the data drift as well. We can also use it for production deployment. So for deploying your models, you can integrate it with MLflow or Hugging Face Hub, or even some from AWS like SageMaker. Then you can deploy model to these places, and then you can make inference. Inference is nothing but you can make predictions out of that. And once you have deployed it, the next step is to model monitoring. And you also have can check if the model is taking a lot of time to make predictions. So you can monitor the latency, throughput, and how accurate the outputs are. You can also do A/B testing before you roll out your model to every user. You can do that. In case of collaborative experimentation, you can share your analysis across the teams. Whatever analysis you do, you can share it with the other members of your teams as well. You can write reproducible prompts so that every member, they don't have to write their own prompt, but they can use the same prompt. Access shared experiment tracking. So whatever you do, you can also have this tracking of those experimentation. And you can also enforce data governance. So in data governance, maybe you want to follow some of the standard protocols like GDPR, in case if you are in Europe, and if you are working with some healthcare data, then you can follow the guidelines of HIPAA. Now for resources, so you can check out these pages to get more information about the MCP. So this is their website, and this is the official GitHub page from where you can download some of the codes, and then you can do the experimentation. And you can also get some examples from here about the servers. You can also join their community on Discord or Slack to get more information about their upcoming releases, or maybe events or webinars, and etc. Now let's look at the demo. So this was the theoretical part. Now I'll show you demo how the MCP works. So I'll open this VS Code editor. I've already prepared code. I'm just going to run and show you the output. And before that, I'll explain you the flow of this code so that you understand what we are doing here. So I have this folder MCP Python code assistant, and here I will be using Llama 3.18 billion models for this tutorial purpose. Now, inside this main folder, I have three different folders. One is example. Inside example, I have made three Python file here. Now, in this file, the ml underscore pipeline.py, here I'm writing one class ml pipeline, and this class will load your data and train the model. The second file is sample underscore class dot py. Now, in this file, I have written just a class calculator, and this class has three different methods: add, multiply, and get history. Add will just add two numbers, multiply will multiply, and then get history is nothing but it will just return this self here. Now, the third file is sample underscore script dot py. And here also I have just written some example codes. One is the one function is greet. This will just return hello and whatever name you write here. The other function is calculate sum. This will calculate sum of numbers. So these are the example files in this folder example. Now we have MCP server, and inside this, I'll come back to this MCP agent later because there is only one Python file here. So in MCP server also, we have two folders, tools and utils. In tools, we have one file which is analysis tool. Now, in this analysis tools files, we have different functions here. The first function is define analyze code structure. So whenever the client will call, or whenever the LLM thinks that it wants to call this function, analyze code structure, then it will call this function. And what this function does is it will analyze the code, and then it will give you the output. For example, whether the code type is a script, whether it has classes written, or it has functions in it, and then it will generate summary. So success will be true. If there are classes, it will tell you what classes are used there. If there are functions in the code, then it will tell you what functions are used here. And whatever import statements we have written, whatever modules that we are using, it will also tell you those modules. How many lines are there in that file, it will also tell that and also give you a summary of that. So this is the functionality of this function analyze code structure. Then these are nothing but some exception to handle syntax error. Then there is this another function, detect ML libraries. Now this function will check the code and it will check if there are any machine learning libraries inside that code, and if at all, then it will return what libraries are there. So for example, here in this dictionary, I have categorized these libraries into different groups. For example, for data processing, I am considering pandas, numpy, polars, and dask. If the function finds these libraries or these imports in the file, it will return that as data processing libraries. And if it finds sklearn or scikit-learn or XGBoost, LightGBM, CatBoost, you can extend this list. This is just for the demo purpose. I have kept the list short, but you can extend it. So if it detects these libraries or these modules, then it will return this as machine learning. Similarly, for deep learning, I'm using here TensorFlow, Torch, PyTorch, Keras, JAX. For visualization, it will be Matplotlib, Seaborn, then Plotly, Bokeh. Wherever it detects these libraries in the file, it will return this as visualizations. So this is a dictionary that contains list of these libraries here, and these are just try. These are just if and else statement. So if it gets deep learning library, then it will return as deep learning, and similarly, it will just go and get the keys from this machine learning, and then it will return this type as machine learning. So there are these two codes here in this analysis underscore tools.py file. Then there is another file underscore tools.py. In this file also, I have defined some function, read local file. Now, this function can be used to read local file. You have to give your file path here, and then it will do the try if it is success or not. And then this is going to be the output of this function, return success true, what type of content it is, the file path, the actual path of that file, then file size, and also how many lines are there in that code or in that function. Now this function will read GitHub file. I will pass one URL to read a file from GitHub, and also I will write a prompt to check how it can analyze the file that I have read from GitHub. So you can provide a URL here, GitHub URL, and then it will read the file from there. So this is the function that will do the reading, and there are some so in return type you will have this success, whether it was successfully read or not, or whatever content it has, URL, the file size, and how many lines are there in that file. And these are just some exceptions here. Then the next file is quality tools. Now inside this also there are some function, generate docstring. Now what this will do, let's say I read some function and I want to generate a docstring for that function. So I can just say that please write a docstring for that function, and it will write it for us. So this is the job of this function, to write docstring. There are some just conditions here, and then exceptional handling. And in here in the return, it will give us whether it was successful or not, and suggestions, and also the summary of the docstring. Then the next function here you see is explain code line by line. Now whatever functions I am telling you, these are known as tools. We call it as function, but in GenAI we call these functions as tools. So these are the tools that will LLM will decide which tool it wants to call. We will not explicitly say that please go and call this explain code line by line. Whatever prompt we write, it will go to the LLM. LLM will decide what tool it wants to call for this particular task. Now, the main goal of this explain code line by line function is, so let's say I have I want to say uh, from this function in here in this examples you have seen ML pipeline, I will say please explain the class ML pipeline line by line. So it will explain this class line by line. That is the purpose of this function. Uh, uh, Explain code line by line. We will use it for that. Then this is generate line explanation. This is also a similar function. the LLM can decide whether it wants to call that function or this function. There is a little minor difference here. And yeah, these are the two functions only in this quality tools. Now, let me close this tools here. Let's go to this utils. In utils, I have not written anything. So utils is empty. You can write anything if you want. This is just for the purpose of demo. I kept it blank. So now the final thing is server. So this is the server, and whenever you are creating server and whatever tools you are writing, you have to use this decorator at the rate mcp dot tool. Now here I'm making some imports. So from fast mcp, import fast mcp. Now from this tools here in this we have this MCP server. So inside this, we have this tools functional for tools folder. And inside this tool folder, we have this file tools, analysis tools, quality tools. So whatever functions I have written here, I'm just importing those functions from there to this server file. So for example, from tools dot this file tools, import read local file function, read GitHub file function. And similarly, from this analysis tools, I'm importing analyze code structure, then detect ML libraries functionality. From this quality tools file, I'm importing these two functions, explain generate docstring and explain code line by line. So there were two functions, they were similar. That's why I'm importing just one function here. Excuse me, explain code line by line. Now you have to create a server here. For that, you have to call this fast MCP function. And here you can give any name. I have written here Python code assistant. You can give any name to your server. And then you have to now register all your tools here. So for that, you will call this decorator mcp.tool, and then you will register these tools. So whatever I have imported here. So the first one is read local file. So I'm registering that here, read local Python file, and then this will return this read local file here. This function is, and then the second one is read GitHub Python file, and this will return read GitHub file that I have imported here. So I'm going to register all of this functionality as MCP tool so that I can use it, or so that the LLM will decide which tool it wants to use. So this server file will have nothing but this functionality register as a tool and nothing else in this. And here you can see then I'm just making these print statements here. And then you have to call this mcp.run, the MCP server that we are creating here in this line number 8. You have to call this. So you can see that this server.python file is very clean. Just make the import statements and then just register all of this function as mcp.tool, and then you can call your run function to run your MCP server. Now let's look at the agent. In agent, we will have client. So client is what you have to you will use it. Now, instead of writing this client.py, I've written this as agent.py. You can name it anything, a client, agent, or anything you want, but uh, this is nothing but your client.py file. Now, in this file, you will write, what you have to do is you have to define all of these tools that you have written in MCP server.py. And in this agent file, you have to also make use of your LLMs. So for that, I have, you need a key from any of the LLM that you are using. Maybe if you want to use it from OpenAI, so you have to create a file .env, and inside this you have to define a variable. So here in this case, I'm using Grok API key. So I'm going to define this Grok API key and then paste the API key here. So let me show you. So this is the Grok API key and this is the actual API key. This API key will be invalidated after our session. So do not copy this. This will not work. Just for the purpose of demo, I'm keeping it here. And please do not share this with anyone because these are your personal keys. I'm even even I'm going to delete this after our session. So this key will be invalidated. Now, once you have defined your API keys in this .env file, it is now secured. So you can easily call it here or easily load it here using this function load.environment that you will import it from .environment file. And then here you can define your, yeah, and you will also use here async functionality. So you will see that before writing my function, I'm using async here, and you can make this import statement from here, import asyncio, and then you can use it. Let me scroll down. So when I will call this function, I will create a instance of this Grok, this Llama 3.18 billion model from this Meta, which I will be using from Grok because Grok provides you free API or you can use it for free. And I can, so what you have to do, you have to go to this Grok, or let me show you. I'll open this Chrome. So you don't need OpenAI because that is paid one. And here you can type in Google Grok Cloud. Then you can click on this Grok Cloud Home. Okay, there is some error I see. Okay, right now I'm seeing some error, but you can come on this website console.grok.com. You can log in and then you can get your API keys for free and you can use it here. You can provide it in this environment file. So here I'm just creating a variable LLM to store this LLM model, and then this API key I'm providing here. Now here you have to give the path of the MCP server. So my MCP server is inside this folder MCP underscore server and then this server.py. So this is the path I'm giving for this MCP server. And then you have to define here. And one more thing, you have to use this multi-server MCP client functionality from LangChain. So here we are using both LangChain here, and from this LangChain underscore MCP underscore adapters dot client, we will be using or we will be importing this class MCP server client here, and this will help us to. Now, the name itself tells us that this is multi-server MCP client. That means you can have multiple server. And yeah, let me tell you one more thing. Not just one server here. So here you see there is only one server file, but you can have hundred of servers. So you can have hundred of server one, two, three, or whatever name you write. You can have hundreds of servers or even thousands of servers. And using these functions, you can connect to all of the servers and you can call the functionalities from all of the servers. So this is why the library name is also multi-server MCP client. and then you will register here your this language is going to be Python, and transport type it is standard input output, because we are not making any uh, live API calls here. So that's why it is stdio. And then this function will tools get tools here. So whatever tools we have registered in this server.py file, we will get all the tools from here. And then there are some just try and accept here. So this is not, yeah, here we have this handle query. So it will do the pattern matching here. It will do some of the pre-processing. It can convert the text into lowercase here. For example, if you are providing, let's say github.com in uppercase, so it will convert it into lowercase. It will do all those pre-processing here. So here I have also written this comment. So pattern one is extract file path for local file. So this will just do the extraction of the file path. This will check for context-based queries after checking for URLs. And here it will just read the files. Then handle context query. Yeah, this will handle queries about now whatever code you fetch now, and you want to ask some question about that code. So this will do the handling of that code, that is the context. Then I'll just tell you some of the important functionality, because this file has a lot of functions. Now, this function will handle the reading of files. So it will take the file path, and then it will check, could not find a valid path in your query, or if you have written some wrong path URL, or maybe wrong path here. So it will give you an error. Then this function will do the analysis of your file, could not find a valid file path, and then it will use some tools here to read your local files. This will do the ML detection. It will find whether it has detected machine learning libraries or not. And if it has, then it will print detecting ML libraries and the file path from wherever path you are providing. So it will give you the list of ML libraries that it has detected. This is for documentation, and this is for handle explanation. I mean, we have already seen this in our tools examples file. So these are all those functionalities that I have written here. Now, let's see how this works. So I have written some of the queries in advance so that I can show you without I have to think about it. Uh, what question should I ask? So I have already have some examples that I can use. For that, first of all, I am going to call, or I'm going to run this client. I will type here Python and then MCP agent, this folder, and inside this folder we have this agent.python file. Let me run this. Now this will run. Python code assistant MCP powered initializing. Now here in the output you will see it's saying these are the available tools that I can use. Read local Python file, read GitHub Python file, analyze Python code, detect ML data science libraries, generate missing doc string, explain code lines. And if you want to stop or you want to exit, you can type this exit or quit. Or if you want help for some example queries, you can type help here. Now, let's start with the first query that I have written here. Inside this examples folder, I have this file sample underscore script.py. So I will ask, I will write it here and I will ask it to read the file, whatever code there are in this file sample underscore script.py. I'll paste it here and then press enter. Now you see reading file. Okay, we already got the output here. It says reading file example in that folder examples sample underscore script.py. And if I open this in this file, there are two functions, greet and calculate. Now you will see here, we got a nice description here, a simple Python script example, or you can see here this we are returning here. And whatever functionalities or functions that we have written here, all of them are returned here. And it is now asking us what you want to do next, whether you want to analyze this code, explain this code line by line, or generate documentation for this code. So you can write here analyze or okay, analyze this code. So now we got the output here. It says there are total 13 lines in this files. So that's correct. You see, it is ending on this line number 13. Classes 0. There are no classes defined in this file. Functions. There are two functions. The first one is greet and the second one is calculate sum. Imports. It says there are two imports. That's correct. We have imported OS and the second is sys module. Okay, here you can even see the description. Imported modules OS and sys, functions greet and calculate sum, and summary. So it has given us a short summary code type. Function based contain two function, two imports. Now you can even ask follow-up question. Explain this code line by line. So let me copy this from here. Or I will type it here. Explain this code line by line. Now let's see what we get. Okay. So now here we are getting the explanation. Explain this code line by line processing. And here it says there are total 14 lines. A simple Python script example. It is a documentation string, doc string describing the function or class. Import OS, import statement brings in the OS module or library for use. Import sys, import statement bring in the sys module or library for use. Then there is this space here. There is nothing. So it is empty line. Then there is this function greet, define a function named greet, a reusable block of code. And then what it does, this function return statement sends a value back to whoever called this function. That means whatever name you type here, you will get the output hello and that name. Then line number 7 is blank, so it says it is empty. Then the next function here is define calculate sum, defines a function named calculate sum, a reusable block of code. Then it returns sum of numbers, sends a value back to whoever called this function. So whatever number we will get, it will send a value back to it. Then this conditional statement executes code only if the condition is true. that is if name is equal to main. And then this is the print statement, displays output to the console or terminal, print calculate. So this example here, print statement display output to the console or terminal. So you see here, we have tried these three questions, analyze this code, explain this code line by line. Okay, this one we haven't tried. Let me try that. Generate documentation for this code. I will write here, generate documentation for this code. Now we get the output here. So documentation analysis found two items missing docstring, two functions and zero classes. Now this one function is greet. It says greet argument name, description of name, returns description of return value. So this is the docstring it is suggesting for this function. Then there is the function calculate sum. We have this argument numbers. This one, it says description of number. Number is nothing but description of number. And then also it returns description of return value. So this is a documentation it is suggesting. Now let us look at some other examples that I have. I can even write this, read examples from this sample classes. I'll just paste this here. So in this file sample underscore class, we have just one class here, calculator. It says file read successfully. There are total 18 lines. Yes, there are total 18 lines here. And whatever functions there are in this file, uh, there is a class, not function. There is this class calculator, and these are the methods inside it. So it has returned correctly, and it is asking us if I want to do some analysis of this code, explain this code line by line, but I'll skip this. Now I want to read a file from GitHub. So this is the link. I'll copy this and I can even show you this. This is my own GitHub page. Let me remove this and let me show you what I have here. So here I have one Python file app.py. Now let's see whether this can read our GitHub file or not. I'll paste it here. It is saying fetching from GitHub. Okay, it has fetched the code from GitHub here. So we have this import numpy as np and then flask, this same code. And the last line is flask app.run debug is equal to true. Now we can ask follow-up question from this GitHub uh, GitHub one. So I will say analyze app.py from GitHub. Now you can see we get the output here. It says the code type is function based. There are 21 lines in this code. There are zero classes, two functions. So there are two functions here. One is home and the second one is predict. There are three import statement. So ones, two, three. And the modules it has imported is flask, pickle, numpy. And then functions, there are two functions is home and predict. Summary, it is giving us a very brief summary here. And let me ask a question, analyze predict function here. So we have this predict function, you see. I will ask a question, analyze this function. Okay, I got a error this time. Error docstring type grok.com internal server error. Okay, there is this error is from grok. Let me try again. Okay, there is some, I think, error on the grok. Let me try this query. Okay, so I was facing issue only while analyzing this predict function. Mm, I'll have to check why, because when I checked earlier before this session, it was working fine, but I'll check later what happened. So analyze examples from this. We have already seen this sample script.py here only. Okay, now let me ask this question. What is the structure of, or even a better one? Let's go to this ML library detection. Yeah, this this is interesting. So here I'm asking what ML libraries are in example ml.pipeline in this function or in this script. I'll paste it here and press enter. Yeah, it says that there are 21 lines. That's true. We have 21 lines here. And yes, is ML or data science code? Yes. Project type machine learning. Total imports 3. And detected ML libraries, pandas, numpy, and sklearn. So here we will see pandas, numpy, and sklearn. These are the ML libraries it has detected. Now by category, for data processing, there are two libraries. One is pandas and the second one is numpy. For machine learning, there is one this sklearn. So it has correctly identified the machine learning libraries here. Now let's, yeah, documentation. Okay, let's ask this query, because this script sample underscores dot script dot py, this doesn't have any machine learning libraries here. So let's ask if this script has any data science libraries. This appears to be general purpose Python code. Yeah, so it has not detected any libraries here. You see no ML or data science libraries detected. This appears to be a general purpose Python code. It has correctly identified that there are no machine learning libraries used here in this sample.script.py. Now let's see if, yeah, there are many examples here. You can try it out. I can share this code with you. Let me just take one last example, because then you can experiment yourself as well. Okay, walk me through. Yeah, I'll take this one. Walk me through examples. This, yeah, here. I will paste it here. Walk me through example, or just it will give us a walkthrough of this ML pipeline file. So it says there are 21 lines. Detection is complete. And then detected libraries here for data processing, pandas, numpy, machine learning, sklearn, and so on. So you can continue. You can ask different questions and you will get the output. You can extend this server MCP server.py. You can add more codes here or more tools or more functions here. You can extend the functionalities in the server.py. You can even create more files in these examples, or even inside this script you can extend the class or even functions. So this is a very, a basic concept of how MCP work. You can put more tools here. You can even use some APIs to get live data. For example, you want to get live information about maybe weather or some flights details. So you can put those API, but you need to then get the API keys of those website, and you have to put those API keys in this environment.py file and call it here in this agent.py, and you can even get the real-time data as well. This is how the MCP works. You must have one server file and the one client server where you define all your tools, and client from where you want to use it. Now let's take some question and answer. If you have any question, please feel free to ask. I will be very happy to answer your questions. Oh, this
So
is
we
the
do have
reason.
about 20 minutes left, so if anyone would like to ask a question, the chat is available. Yeah. And thank you, Amir.
Thank you very much.
Okay, it seems that there aren't any questions right now. We could maybe go through some of the other examples if you're up to it, Amir.
Uh, okay.
Mm. Thank you.
For example, let's say I'll ask this question here. I'll copy this question from here and then I'll paste it here. So I'm asking if there are any docstring missing in this ml.pipeline. And if I open this file, this script here, you can see that there are actually no docstring, just the functions here and the class. So let's see what I see in the output. Yeah, it says that found 4 items missing docstring. That's correct. 3 functions, the load, train, and this init. It says these are missing, and the class for this init, it is suggesting, it is giving us a suggestion what docstring we can write here. One is for argument, what argument we have, and the other one is for return statement, description of return value, whatever we are returning. Then for the function load data, here also we don't have any docstring here. So it is saying that you can have a docstring about the argument, and there is one argument here. This is file path. So description of the file path I can write here. I mean, for example, you have to just write these quotes, and then you can write it takes input as file path or location. So this I can write it here. Then return description and what it returns. So I can even write that. It will then, return the file. So I can write this docstring here. Then it is also suggesting for train function, this one. Now it takes two input x and y. So it says for x, you can write the description of x, and you can also write the description of y, and also the docstring for the return. Whatever it is returning, whatever value it is returning, you can write it there. Now classes missing docstring 1. So for this entire class also, the docstring is missing. It is suggesting to write a docstring for ML pipeline class. So this class ML pipeline, and you can write something like this class provides functionality for ML pipeline. So this I find it nice. I can just copy it from here and then just write quotes and put that docstring here. So this this makes it very easier for me, just copying from here and then pasting it here if I like the suggestion. Otherwise, I can write my own docstring here, but I know where I have to put it. So you can see it is giving a suggestion where we can write it. And now this is user friendly, so someone or someone who is reading your code, they will understand that what is the purpose of this class and what these functions are doing. Then you can also go through some other examples. So we have already seen this, analyze this code, explain this code line by line. There are some tips. Now, after reading any file, you can ask follow-up question. You can ask follow-up question to this as well. It's not like that you just ask one question and after that it will not give you an answer. It will have that context, and you can ask some follow-up question as well. Context is remembered within the session. I mean, until you close this session, the context will be remembered, and you can try out some new features. You can add it in that code and you will have some new features as well. Yeah, so security is a major concern for GenAI applications. And
Excuse me, Amir. Could
yeah,
you read the question out loud so everyone can hear it because other people don't see it, only the panelists do. Thank you.
okay, sure, sure. Now there is one question from Milan. So do you have some security concerns or some best practices from your perspective in implementation? In the slides, you have listed that security is implementation of MCP is on own basis, independent lot. So just a few about it if you have experience. Yeah, so for security purpose, you can actually follow their official documentation, because there are different suggestion, and it also depends on the applications that you have created and the purpose of that application, whether you want to keep it inside your organization, keep it private, or it is limited to only few peoples, or it is open for all the users. So it depends on that. You can get more idea about the security in the official documentation. They have a lot of good information about that. You can just go to, and I'll also tell you their official website. So you can just type here MCP, and this is their official website. Okay, this is also down right now. And there is, let me see, awesome. There is one awesome MCP website, awesome MCP servers. Now you can use some of the servers from here for your real-time information. If you want to get some real-time information, you can use some of the servers from here, but some of them are paid. You can search, for example, there is this from Bright Data, Thor Data, and this server, you can use this server to extract and interact with a web application. You can just open it and get more information about it. So there are many servers hosted on this website that you can use it for your project purpose. You will get the overview. Is a gateway to giving AI assistant true web capabilities. So because you know that ChatGPT has some limited information, the data is trained, for example, let's say July of 2025, you don't get the real-time information. In that case, you can use the servers to get the real-time information. The data is updated. No more outdated response. No more I can't access real-time information. You will get the real-time information or the updated queries to your answer. And it can be used for e-commerce, market analysis, agents, content creation, some research. So this server, but there are many servers. You can try out which one you like. You can check which one is free, and you can use even that one as well. If there are any other questions, please feel free to ask.
Thank you, Amir, for the tutorial and the demonstration. At one point, you mentioned that attendees could also test out the functionalities of your demo code. Is it available somewhere, or could they reach out?
I can share it.
Mhm.
Is it possible to share in the chat, or should I email?
You can try it in the chat.
Okay,
If not, we can figure something out.
I think I can share. Oh, I'll have to create a zip file first. Okay, I have shared it in the chat.
Okay, thank you. Could you please select that everyone can see it because currently it's set to only host and panelists?
Oh, I'm sorry.
Yeah, no worries. It's something Zoom does by default.
To there are two options.
So if you could choose everyone.
Okay, let me check how many options I see. Host and panelist and DSC Europe support host. I see only two options here.
I can share it then.
Yeah. That would be great.
Okay, I also did the same thing. Now I'm sending it to everyone. Here, everyone should be able to see it and you can download it. And thank you once again very much, Amir, for uh, such a great demonstration. Yeah, so that's it, everyone, for this tutorial. We have one more session starting at 15:15. Thank you so
Thank you
much.
everyone for joining this session and thank you for your support.
Thank you. Bye.
Bye. Thank you, Simona.